Hey everybody, welcome to How to Solve by Computer series. This session is about the writing algorithm to remove the duplicates from an array. Let us understand the problem first. You have to remove all the duplicates from an ordered array and contract the array accordingly. Remember, it is an ordered array. Ordered array means elements are arranged in ascending order. Let us take this example. So we have some of the duplicates in this array and our output should be only these values. So removing duplicates we will get 3, 8, 12, 25, 27, 32 and 45. So now our array has contracted, removing the duplicates. One way to solve this problem is we can have this original array, we can create another array and try to copy the elements. Okay, first element will be copied, then you will be comparing this element with the second element. If they match, they don't copy, and you move on to the next element, and if they don't match, then you will copy this element, and thereafter you will compare this 8 with 12, and if they are not matching, you will just copy it to the new array like that. But this type of algorithm is not efficient because we have a original array and you are trying to create another array which requires more space. We need to design an algorithm that will minimize the space. So let us see the same array. In the same array itself, you have to bring this output. Let us see how we can do that. Now, take this input array A, and these are the positions of the array. Always remember that your array position starts with 0. Now this refers to the index of the array. Now what we do is, in order to remove the duplicate, we need to move the elements before position. Okay, so we see that 3 and 3 are duplicate. So we try to move this 8 to position 1. Next what we do, 8 and 12 are not equal, so 12 should be moved to the position of 2. Next again 25 will be moved to the position of 3. Now here we find duplicates. So 25 we have moved to third position. So 27 should be moved to the position of 4. Then similarly 32 will be moved to the position of 5. And here we have duplicate. So remove, omit this. Now compare 32 and 45 and you have to bring 45 in the position of 6. So that is how you get your output. Now how do you develop an algorithm to make this process? Now how do you identify the duplicates? When adjacent elements are equal in value, then we say they are duplicates. What do we do is, we'll compare a of I minus 1 and a of I, where I is referring to the index of the array. Say for example, I is equal to 1. Then we are comparing a of 1 with a of 0. If they are equal, then we say it is a duplicate. Similarly, we'll proceed comparing the successive elements. So we'll compare a of 2 with a of 1. Then we'll compare a of 3 with a of 2. Whenever there is duplicates, then we'll move on to the next successive comparisons. Now, let us take this example. So simple example to find out, to identify the duplicates. Okay. Now what we do is, we'll be using a variable I. Okay. I will be initially pointing to second position, because I am comparing the position with the previous value. Okay, so I am comparing a of 1 with a of 0. That is why I am making I is equal to 1 initially. Now what do? I will compare with the previous value. So a of 1 is compared with a of 0. That is a of I minus 1 and a of I. I is 1. So a of I minus 1 would be 0. So I am comparing. So they are not equal. Okay. So then what I do is I will go to the next successive comparison. So I will increment so that I will go with the next successive comparison. So what is my next successive comparison? It is a of 2 compared with a of 1. Now I find that these two are equal, which means there are duplicates. Now what I do is they are equal. So what I do is I will introduce another variable j, which will tell me so far how many elements are unique. Okay. So how do I set my j? J is nothing but I minus 1. Okay. So far I have found only 2 unique elements. Okay. That is what this indication of j. So this j will play a role like where you want to insert the next unique element. So that is the purpose of this j. Next, what do? I'll move my I position and I will try to compare. They are equal. So what do? I will just move my I to the next position and I compare with the previous. They are not equal. Now what do? So this 27 should come to position 2, which means I need to increment this j value and I will copy the value present in this 4th position to the 2nd position. That's it. So what I do is I will increment my j and then I will copy the element at the current position of I to that of the position of j. So what do? I will just copy a of I to a of j. That's it. Okay. So I will copy this to this position. So now you can understand the importance of using this j variable. Okay. So now this becomes 27. Next what happens? Again the process continues. So I will be incremented and it will go and compare with the next successive element. Now here again they are not equal. Not equal means what do? I will increment j and I will copy that value in this position. That's it. So I will increment j and I will copy 32 here. So this will be 32. Next step, to increment your I and compare with the next successive positions. So now they are equal. So I don't do anything. Okay. So if I increment I, then it will go out of bounds of the array. So I need to stop. Now it clearly says that the position j tells me the last position of my array. Okay, so my array will have only these two values after removal of the duplicates. Now, so n, that is the number of elements, is set to j. Okay, so j is will be having 3. Actually, j should be that is n should be j plus 1 because it is starting from index 0 now. So it will be j is the position, that is the last position. When you say the number of elements, it will be j plus 1. Okay. Now, what is your input? You have to give an array of n elements which will have duplicates. Now, what is your process? As I told you, you will be using a variable, index variable I, which will be pointing to the second element first. Okay, second element of the array. So I is equal to 1. Use a variable j to refer the unique elements present in the array. Okay, so we'll be using this variable to refer the unique elements. Now what do? I will compare the successive pairs a of I minus 1 and a of I. That is what I did until a duplicate is encountered. Okay, so you have to keep on comparing this until a duplicate is encountered. As soon as a duplicate is found, then you set your j to the count of the unique element. So how do I do this process? I have written that step here. While a of I minus 1 not equal to a of I, and I should be less than n minus 1. It should not exceed the bounds also. Okay, I is less than n minus 1. What do? I will increment. Okay. Once I found the duplicate, Duplicate means what? A of I minus 1 and A of I are equal. Then what do? I will set j is equal to I minus 1. So remember the process what you have seen in the last slide. The same thing I am writing in the statement. Now next what do I do? So what do? I will be repeating this process as long as your I is less than n minus 1. So if your next pair is not a duplicate, then what do? I have incremented j and I told you that move a of I to a of j. That's it. Okay. So this representation only I have just used this while representation while I is less than n. Then I have to increment I and this is not duplicate. This is what is represented as if a of I minus 1 not equal to a of I. What do? Increment j and I have to move a of I to a of j. Okay, so that's the thing. And your number of elements is equal to j plus 1. Okay, so this process should be keep on repeated till your I is less than n minus 1. That's it. Now, your output will be the same array, but now your n will be only j plus 1, not the original value. Okay, so you have to write that array. Now, converting into the algorithm, what do? Read an array of elements. I'm sorry, it is 0 to n minus 1. Then initialize I is equal to 1. Repeat step 5. If a of I minus 1, that is successive elements are not equal and as well as I is less than n minus 1, what do? Okay, so what do? You just increment your I. Now, next, it will come to this step when a first duplicate is found. Okay, first duplicate is found means you have to set my j is equal to I minus 1. Okay, so we are doing this till you find the first duplicate. After that, what do is you will be repeating the steps until I is equal to n minus 1. That is I reaches n minus 1. You will be repeating these steps. What do you repeat? You will increment I by 1 and you see the duplicates. If they are not equal, then what do? Increment j by 1 and you have to assign. So if they are not duplicate, I have to increment the j position and at that position I will copy my a of e. Okay, then you have to do this process repeatedly till I is less than n minus 1. Remember, whenever I use repeat, after this 8 and 9, again it will go to the 7th step. It will check this condition. Only if it is false, it will come here. Okay, so this is what you need to understand. Whenever I repeat, write this step repeat. See here also, step 5 is repeated means it will come here. Again it will go and check these conditions. Okay, so if they are true, then it will come here. Otherwise, if it is false, it will go to the 6th step, like that. Then you print the array. Okay, so that's it. That's simple this algorithm is. So we'll go for a verification whether it works fine. So we'll take the steps. Okay, I have taken one array which has some duplicates. Okay, now my n is 8 number of elements, but my position is from 0 to 7. Next, what do? I will keep I is equal to 1. I'll keep track of this j. Now, initially j will be assigned nothing. Okay, now what do? I will compare a of 0 with a of 1. Okay, so a of 1 they are not equal. Okay, not equal means what do? I will just increment my I. That's what I do. Similarly, I will be comparing I is less than n minus 1. Both should be true. Only then I will proceed. What is the proceeding step? I will increment my I. Next step, I will be comparing a of 2 with a of 1. Okay. So, a of 2 is compared with a of 1. They are again not equal. And as well as I is also less than n minus 1. So, what do? Increment I. Okay. Go to the next pair comparison. So, here I see that a of 3 and a of 2 are false. They are equal. Okay. So, this condition becomes false. But I is less than n minus 1. But false and true. Then it becomes false. Okay. So, false means what do? I have to set my j. Okay, so this is the first duplicate I found, and I will set my j to 2 because till that we have unique elements. So that is what the indication is. So j is set to 2. Okay, how do I set my j? J is nothing but your I minus 1. Okay, so that is what is your j. Next, what do? I will just check whether I is less than n minus 1. Then what do? I will increment my I. Okay, and go on with the successive pair comparisons. Now I see that A of 4 and A of 3, they are equal. Okay, so this condition is false. But again, I is less than n minus 1. But false and true. Okay, it will become false only. So what do? I have just rewritten the array for our reference, and I is incremented. Okay, so I becomes 5. Then again, what do? I will compare A of 5 with A of 4. Now they are not equal. Okay, so this condition is true. True means what do? I will also check. True means what is that happening is you have to copy the element present in the fifth position to the position pointed by j. Okay, so now I am having at fifth position, that is denoted by my I as 5. At this position I have 6. I have to move it to a position that is pointed by j. J is 3, so I will just move this position, to move this element to this position. Okay, understand? So what do? Whenever I find some element which is not equal, what do is I will be incrementing my j. Okay, so j is previously 2, so it is incremented to 3, that is referring to the next position, and I will copy that element. Okay, which element? This 6. 6 is copied to here. Okay, so this is what is happening. Next, I is incremented, so I will be 6, and again 6 and 7 will be compared. They are not equal. So what is that I need to do? This 7 will be copied here, which means j will be incremented, and at that position this value will get copied. Okay, so that is what this process is. So next what will happen is again it will compare the 6th position with the 7th position, and we see that they are equal. Okay, so they are equal. So this condition will be false. So what do? So I will just increment this value, so it becomes 7. Now 7 is not less than n minus 1, so I will stop. That's it. Okay, so I will get the values 2, 4, 5, 6, 7. That's it. So this is how you can verify your algorithm, and it is working perfectly fine. So thank you for watching. Subscribe to my channel to watch my next video. Hope you have enjoyed. Thank you.